In 2023, a bit of the primordial solar system will return to Earth. That's when NASA's OSIRIS-REx OriginsSpectral Interpretation Resource Identification Security Regolith Explorer mission will return a sample of the asteroid Bennu, a carbon-rich rock hosting traces of the early solar system. While there, the mission will conduct an in-depth study of the rocky body, learning more about how sunlight can shift its position, before gathering a small sample to return to Earth. The $800 million OSIRIS-REx mission was named a finalist for NASA's New Frontiers mission class in 2009, along with a mission to study Venus' surface and atmosphere Geochemical Explorer, or SAGE, and the Moon Moonrise. It was chosen as the winning proposal in 2011. The New Frontiers program is a series of medium-class spacecraft missions that are intended to help us better understand the solar system. OSIRIS-REx is the third mission chosen. The previous selectees were New Horizons, which flew by dwarf planet Pluto in 2015, and Juno, which arrived in orbit around Jupiter in 2016. OSIRIS-REx launched on September 8, 2016. After spending 2 years traveling through space, it will arrive at Bennu in 2018. This included a brief return to and flyby of Earth in September 2017, to pick up speed for the journey. OSIRIS-REx will follow in the footsteps of Japan's Hayabusa, which in 2010 became the first spacecraft to bring a bit of an asteroid back to Earth. Coincidentally, a successor Japanese sample return mission called Hayabusa 2 is on its way to asteroid Ryugu, also known as 1999 JU3, for an arrival in 2020. OSIRIS-REx, however, is the first U.S. asteroid sample return mission. The bits and pieces left over from the formation of the planets, asteroids carry the blueprints of the early solar system. Studying them allows scientists to see what the early solar system was like, and get a handle on how planets formed. NASA's Dawn mission visited the asteroid Vesta before moving on to the dwarf planet series. In contrast, OSIRIS-REx will bring home a piece of Bennu for in-depth laboratory studies not possible while orbiting in space. The team hopes to collect at least 2 ounces 60 grams of material to achieve their scientific goals. Understanding how asteroids form will not only provide insight about the early solar system, but also help scientists better understand their makeup today. That could be helpful should any space rocks threaten to collide with Earth. It could also assist in future efforts to mine asteroids. The mission will develop important technologies for space exploration that will benefit anyone interested in exploring or mining asteroids, whether it's NASA or a private company, Dante Loretta said in a statement. Loretta, a planetary scientist at the University of Arizona, Tucson, is the principal investigator for OSIRIS-REx. Loretta was previously the co-principal investigator along with the University of Arizona's Michael Drake, who died in 2011 at age 65. OSIRIS-REx will also help astronomers study the Yarkovsky effect on asteroids. Heat from the sun provides a tiny push that can affect the movement of an asteroid. Although the push is minimal, it can build over time, helping to change the path a space rock travels. But the effect can be a challenge to study, as it varies based on the shape of each asteroid. The knowledge from the mission will help us to develop methods to better track the orbits of asteroids, Jim Green, director of NASA's Planetary Science Division, said in a statement. Once OSIRIS-REx reaches Bennu, 5 instruments on board the spacecraft will study, map and analyze the asteroid in unprecedented detail. OSIRIS-REx Visible and Infrared Spectrometer OVIRS. By measuring visible and near-infrared light, OVIRS will hunt for organics and other minerals. OSIRIS-REx Thermal Emission Spectrometer OTS. Using the thermal infrared, OTS take Bennu's temperature and map mineral and chemical abundances. Together, OVIRS and OTS will map Bennu over a wave of interesting wavelengths to help select the best site to sample the asteroid. OSIRIS-REx Camera Suite OCAMS, a 3-camera suite will help map Bennu. Polycam, the largest, will acquire the first images of Bennu from 1.2 million miles 2 million kilometers and capture high-resolution images of the sample site. MapCam will hunt for satellites and dust plumes around the asteroid, map it in color, and take the photographs to create topographic maps. SAMCAM will document the collection of the sample and its capture. OSIRIS-REx Laser Altimeter OLA. By scanning the entire surface of Bennu, OLA will create highly accurate 3D-shaped models of the asteroid. Regolith X-ray Imaging Spectrometer REXIS. Study X-ray emissions of Bennu will help provide an elemental abundance map of its surface. Unlike other imaging instruments, REXIS will examine the composition of the asteroid at the level of individual atomic elements. OSIRIS-REx made a flyby of Earth on September 22, 2017, to pick up speed for its journey to Bennu. At its closest approach over Antarctica, the spacecraft was roughly 10,711 miles 17,237 kilometers from the surface. The flyby increased OSIRIS-REx speed by 8,451 miles per hour 13,061 kilometers per hour and was executed flawlessly. The spacecraft is expected to arrive at Bennu in late 2018. Once the asteroid has been studied in significant detail, scientists will identify a region to sample. That's where the touch-and-go sample acquisition mechanism TAGSAM will come into play. As OSIRIS-REx draws closer to the asteroid, TAGSAM will blast a sample of pure nitrogen gas at the surface. Regolith dust and broken rock blasted from the surface will be pushed into the chamber of the sampler. OSIRIS-REx should touch down on the asteroid in July 2020. To complete all of the planned science, OSIRIS-REx needs to collect at least 2 ounces 60 grams. The goal is to collect 5 ounces 150 grams to account for any errors in measurement. 3 bottles of nitrogen gas allow for multiple collection attempts, and TAGSAM can carry as much as 70 ounces 2,000 grams. To weigh the sample in the low-gravity environment, scientists will measure the angular acceleration of the spacecraft before and after the sample is collected. Although OSIRIS-REx will sample Bennu, it will never actually land on the surface. Contact during the collection process will be brief, lasting only a few seconds. "We kissed the surface," former OSIRIS-REx principal investigator Mike Drake of the University of Arizona told reporters in 2011. The spacecraft will depart Bennu in March 2021 for the journey back to Earth. It will arrive in September 2023 and send a return capsule, which will parachute into the Utah desert. The spacecraft itself will move into a stable orbit around the Sun. NASA's OSIRIS-REx mission will spend 2 years mapping an asteroid before returning a sample to Earth. Credit NASA. Originally known as 1999 RQ-36, the rock OSIRIS-REx will visit was renamed Bennu by 9-year-old Mike Puzzio in a 2013 contest. Bennu is an Egyptian god usually depicted as a gray heron. Puzzio chose the name because he thought TAGSAM and the solar panels resembled the bird god's neck and wings. Bennu is one of several thousand near-Earth objects orbiting within 120 million miles 190 million kilometers of Earth. Among those, Bennu was one of less than 200 objects whose orbit was well known and sufficiently Earth-like. It orbits the Sun every 436 days, and comes very close to Earth every 6 years. It's also relatively large, about 1,650 feet 500 meters wide. Rocks smaller than 650 feet 200 meters spin too rapidly to allow a spacecraft to safely land on them. Only a handful of the asteroids in appropriate orbits were large enough to allow a visit. Among those deemed appropriate, the asteroid has just the right composition. Bennu is relatively rich in carbon-based material. The asteroids that may have brought water and organic material to Earth that helped kick off life would look like Bennu. "We're going for something rich in organics, which might have had something to do with life getting started," Drake said. "That's the idea, time capsule, containing probably the building blocks of life." Bennu's close orbit also makes it a potentially hazardous object, but unlike some media reports, it isn't a definite threat. NASA scientists calculated that there is an 0.037% or 1 in 2,700 chance that it will strike Earth in the last quarter of the 22nd century. For that to happen, the asteroid would need to have its orbit altered in its 2,135 flyby of Earth. Studying Bennu today will help them further calculate the orbit, potentially ruling it out. If the asteroid does collide with Earth, it won't destroy the planet, though it will wreak havoc wherever it touches down. Experts say that the size of the asteroid would likely devastate the local area, but won't cause mass extinctions. In order to cause a global catastrophe, a space rock must be at least twice as large, at 0.6 miles 1 kilometer wide. Still, the advanced warning provided by OSIRIS-REx could help scientists take preventative measures long before the potential impact. Additional reporting by Elizabeth Howell, Space.com contributor.